Okay, we're going to start with Chapter 3, Acute Triangle Trigonometry. And before we get into the new material, we're going to do a little bit of review of right triangle trigonometry from Math 1201. So if you remember from Math 1201, if you have an angle in a right triangle, then you can label the sides of the triangle accordingly. So this one here, which is across from the angle, would be considered the opposite side. And the one that's across from the 90-degree angle is considered your hypotenuse. And the one that's making up the angle of reference that you're referring to, or theta that we've marked here, that isn't the hypotenuse, is called your adjacent. So it's one of the sides of the angle theta, but it's the one that isn't the hypotenuse. So sine, if you remember, is opposite, the ratio of opposite over hypotenuse. Cosine of the angle, theta, is the ratio of adjacent over hypotenuse. And tan of the angle theta is opposite over adjacent. And because those are defined that way, we use the acronym SOHCAHTOA to help us remember the ratios, the right triangle trig ratios. And that would be sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So when we're given enough information, we can use these ratios to help us find missing sides or angles. It is important to note that the opposite and adjacent sides switch depending on which angle you're using. The hypotenuse is always across from the 90, but if you look at this first triangle down here, this angle here, when we're starting from this angle of reference, this side here would be considered the opposite, and this one would be the adjacent. Whereas if we move up to this angle, now it's the adjacent that was in this triangle over here has now become the opposite because we were starting from this angle, a different angle. So this would be the opposite and this would be the adjacent. We can also use the Pythagorean theorem. If we have two sides of a right triangle and we're looking for the third side, we can always set up the Pythagorean theorem, which, if you remember, is, in this case, a squared plus b squared equals c squared, but it's important to note that a should be a leg of the right triangle, and by a leg, I mean one of the sides that makes up the right angle. So this would be leg 1 and leg 2. So leg squared plus your other leg squared equals the hypotenuse squared. Okay, and so when you fill in your information, you can rearrange that to isolate the one you're trying to find and solve. All right, so let's review some of the ways we can find missing information using SOHCAHTOA. So the first one, we've got 3 basic steps. First, we label the sides based on the angle that we're given. So in this case here, we've got this angle. So this side here would be considered the opposite. And the side across from the 90-degree angle would be considered the hypotenuse. So in reference to that angle, we have the opposite and hypotenuse. So we've labeled our sides first. Now we're going to choose the correct ratio. So out of this particular information, we have the opposite and hypotenuse. So we're going to go with sine. And the last step would be to write the ratio and solve. So we've got sine of the angle is 8 over 15. And when you have the sine of the angle isolated like that on the left side of the equation and you're just looking for the angle, you just basically find the angle using inverse sine of 8 over 15 on your calculator. Now, some calculators you'll have to put in 8 over 15 and then hit inverse sine. In some calculators you can hit the inverse sine button first and then bracket 8 over 15, close your bracket. So if I do inverse sine in my calculator of 8 divided by 15 and close my bracket, I get 32.23, so on. So if I'm rounding that off to the nearest degree, that would just be 32 degrees. Okay, so that's it for that one there. Okay, so let's try finding a missing side in a right triangle. So the same basic steps apply. Label your sides based on the information that you have, and then choose the correct ratio, and then write that ratio and solve the resulting equation. So the first thing we have here, we've got this angle given to us. So this side here is the one we want, and that would be opposite the angle that we have. And the side that we are given is considered adjacent to that angle, because this one here across from the right angle would be the hypotenuse. And we have the adjacent and the opposite. So when we look at SOHCAHTOA, when we're looking for the opposite and adjacent, that would be the tan ratio. So that step is done, and now we're going to write the ratio and solve for the unknown. So tan of 38 degrees equals opposite would be x over adjacent, which would be 12.6. And normally when we're looking for the side, we have to isolate the variable. So we can either multiply both sides by 12.6 here, or most students like to put this over 1 and then cross multiply. So you end up with x times 1 equals 12.6 times the tan of 38. You put that in your calculator. You get approximately 9.844. So if we round that off to the nearest tenth, 9.8. And it doesn't tell us what units. I think that's the only question on that page. Yep. Okay, so we just did a little review of right triangle trigonometry from Math 1201. So now we're going to get into new material, and the first section that we're going to talk about is proving and applying the sine law. So when you look at the triangle that's given here on the page, it is a triangle that has an angle of 44 degrees, an angle of 66 degrees, which leaves you with 180 minus 66 minus 44, which is 180 minus 110, or 70 degrees. So we know that this is not a right triangle. So that means we can't use SOHCAHTOA in the triangle as it exists right there now, and we can't use Pythagorean theorem, because they only apply to right triangles. So if we are a little bit sneaky about it, we can basically create two right triangles in any triangle that isn't a right triangle. And so that's where this sine law is going to come from. So now we're going to derive the sine law. So we've just got a picture here of a given triangle that isn't ABC, isn't a right triangle. And what we've done is we've dropped a perpendicular from point B, or vertex B, right down to the opposite side, and made two right triangles, because this would be a right angle, the one that's written there, and then the other side would be a right angle as well. So we've got two right triangles now formed from a given triangle that wasn't a right triangle to start with. So if we look at writing the sine of angle A using the left-hand side right triangle, we get opposite, which is H, over hypotenuse, which is C. And if we look at the right triangle on the other side, triangle B to this here to C, that triangle, then we have the opposite in that triangle would be H over the hypotenuse would be A. So if we take that equation, those two equations, and rearrange each one of them so that the H is all by itself, and we would do that by either multiplying both sides by C or cross multiplying, and you'll end up with either case, you'll end up with H equals C times the sine A for the first one. And this one here, you would end up with, the second one, sorry, sine C over 1 equals H over A. You would end up with H equals A sine C. So because both of these H's are exactly the same side, the two triangles have the same side H. I can't draw straight lines with this pen, sorry. It squiggles, no matter how hard I try. All right, so if we both of those are referred to the same h, that means they must both be equal to each other. So c sine A should equal A sine C. And if we take that equation now and divide both sides of the equation by AC, C sine A over AC equal A sine C over AC, what happens is that the C cancels in the first one and the A cancels in the second one, and that gives you sine A over side A equals sine C over side C. So if you look back at the triangle that we had in the very beginning here, right here, we can see that what that's basically saying is that if we have an angle in our big triangle ABC now, if we know angle A, the sine of angle A, and put it over the side across from angle A, and we know the sine of angle C over the side across from angle C, those two ratios should equal each other. So this is only a partial sine law equation, and if you were to guess at what the other part would be, it would be based on the pattern. If we got sine A over A equals sine C over C, we would think that the last angle, sine B, sine of the last angle over its side across from it, should also equal those two ratios. So this here would be the sine law. That's usually written sine A over A equals sine B over B equals sine C over C, but basically it's just the sine of given angle over the side across from it. Right? Each of those. Each one, that's what it basically is in that form. So now we're going to actually use the sine law to prove some, or find some missing measures. A lot of times in triangles, when we're working with triangles, they use uppercase letters to represent the angles, A, B, and C in this case, and then the sides across of them would be the same letter of the alphabet, but lowercase letters. So across from angle A, you would have side A. Across from angle B, you would have side B, and across from angle C, you would have side C. And it's supposed to be a lowercase, so I'm just going to put a little written C there so you can see that it's a lowercase c. All right. So we're going to try the law of sines now to help us solve for the missing measure that we're asked to find. So I'm just going to bring your attention back to this for a minute. This is one we developed on the last page, but you can easily, by properties of ratios and that, you can easily turn each one of those upside down and have the sides in the top and the angles in the bottom. A over sine A, B over sine B, or C over sine C. This is the one I use most times. So, okay. So the first one there, if you look at, you're asked to find the length of BC, which is basically, BC is this line right here, which is directly across from angle A. So if you want to call that side A. And so we're going to use the law of sines because this isn't a right triangle, so we can't use right triangle trig to find the missing side. If we're going to use the law of sines, in reference to the angles of this triangle, we would be saying sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. So when we start filling in what we have the sine. We do know angle A, that's 83 degrees. We don't know side A, but that's what we're asked to find. Sine of B, we don't know what B is. We're not given what B is. We can easily figure it out, though, because B would be 180 minus 83 minus 43, if we wanted to work that out. And that would give us 54. So that one's... So if you want to put that in, you can. Over side B equals sine of C, we're given that, is 43 over side C, which is 11.5. Okay, so we need to use this one because that has the part that we're looking for. And out of these other two that we have left, because we can't work with all three of them, we need to pick two ratios. We wouldn't choose this one here because even though we can figure out angle B, we know that angle B is 54 degrees, we still don't know side B. So that if we set these two equations, two ratios equal to each other, sine 83 over A equals sine of 54 over B, we'd still have two unknowns and one equation, so it wouldn't be you wouldn't be able to solve it that one equation. But if you picked it, this last one here, sine of 43 over 11.5, and set up your equation of sine of 83 over A equal to sine of 43 over 11.5, you have one equation with one unknown, the A, so you should be able to solve it. So when you have two ratios equal to each other, you have to basically isolate the variable. Okay, so one of the methods when you have two ratios equal to each other, a single ratio equal to a single ratio, you can cross multiply. Okay, let's move that down a little bit. All right, so the first step was to set up the ratios. And then the second step was to determine which two to set equal to each other. Need only one unknown. When you pick the two, there should only be one unknown. So now I can cross multiply. Cross multiply and solve. Okay, so the first side, A times the sine of 43, I usually put the one with the variable on the left, equals 11.5 times the sine of 83. So A sine 43 equals 11.5 sine 83, which is 11.414 if I keep 3 decimal places. And then if I want to get A by itself, I want to get rid of this sine of 43, which is being multiplied by A. So I have to divide it out of both sides. So A would equal 11.414 divided by the sine of 43. It's going to give me 16.7365, so on. So rounded off to the nearest tenth would be 16.7 approximately. And that would be in centimeters because the other one is in centimeters. Okay, so let's try the next question now. All right, so example 2, we got to use the sine law to calculate the lengths of the other two sides of the triangle to the nearest hundredth of a meter. So if you want, you can label your triangle, and I'm just going to deliberately label with different letters this time than A, B, and C. After a while, you probably won't even have to label the triangles at all. But if I do this one, I got sine of P over side P equals sine of Q over side Q equals sine of R over side R. So we fill in what we know. We know that P is 42. We don't know side P, so I'm just going to leave side P. Sine of Q, I don't know, but I can figure out Q very quickly. Q would just be 180, take off the 42, take off the 64. Which, if you put that in your calculator, will give you 74 degrees. So sine of 74 over side Q, which I don't know, and sine of R, I do know that R is 64 degrees, and side R is 14. So when we look at the three ratios there, we need to find the two side lengths. So if I start with this one, the first one, I would need to match it up with the last one, because that will give me only one unknown. It wouldn't be a good idea to match these two up together, because there'd be a P and a Q that we don't know. So if we, off to the side here now, we do sine of 42 over P equals sine of 64 over 14. Cross multiply, and we get P sine 64 equals 14 sine 42. So P sine 64 equals 14 sine 42. Make sure your calculator is in degree mode when you're doing these questions. So P sine 64 equals 9.3678. We want to get the P by itself, so we want to divide both sides by sine 64. And that's going to give us P equals 10.4. If I round that off, what is that exactly? 9.3678 divided by sine 64. It's 10.42 around there. 4226, so on. But if you round that to one decimal place, it would just be 10.4. And then the other one, if we want to find the Q, we need to use the ratio of sine 74 over side Q. And again, I would pair it up with that last one. So this one here would go with this one here. You could use sine of 42 over P because you just found P, but I always go with one that I was given the information, because in case I made a mistake with finding side P. So sine of 64, I was given that information, and 14, I was given that one. And then again, I cross multiply and solve for Q. So Q sine 64 equals 14 sine 74. And that will give us Q sine 64 equals 14 sine 74, which is 13.4576, so on. So then I'd divide both sides by sine 64. And that would just give you Q by itself equals this divided by sine 64 is 14.973, so on. So we round that off to the nearest, to the nearest tenth, that would be 15.0. And again, both of those would be meters. Forgot to put that in. All right, so the next question asks you to find the measure of angle PRQ. So if we set up here, again, P got kind of cut off up there, but that's P up here. All right, so if we have sine of P over P equals sine of Q over Q equals sine of R over R. And after a while, you won't have to write all three of those. You can just start, kind of skip the steps and go right to, because you know it's basically sine of the angle over the side across from it. So if I do sine of P over 6.4, and sine of Q is sine of 80 over 12.4, and the last one is sine of R over side R. So when you look at the information there, if you're asked to find PRQ, that's sine angle R here, you don't know angle R and you don't know side R. So you're not going to be able to start with that one. You're going to have to actually find P first here. and then you can figure out r after. So we're going to find sine of p over 6.4 equals sine of 80 over 12.4. And we're going to cross multiply those. And we're going to get 12.4 sine p equals 6.4 sine 80. And we want to isolate sine p, so we're going to divide both sides now by 12.4. And that's going to give you sine p equals 6.4 times the sine of 80 divided by 12.4. You should get 0.508 to so on. So if you want to find p, then it would just be the inverse sine of that, 0.508 to the, I'm just leaving it in my calculator, that's why I have dot, dot, dot after it. But if you were just rounding it off to 4 decimal places, it would be 0.5083. So inverse sine of that, and that gives you approximately 30.549, so approximately 31 degrees. Now that's angle P, but you're asked to find angle R, so therefore angle R, you don't actually have to go back to the ratios to find angle R, because we got two angles in a triangle. You could just basically, I gotta erase that, looks too messy. So angle R, you could just do 180, subtract the 80 and the 31 degree angle that we just got, and you'd be left with 180, subtract 80, subtract 31, 69 degrees. So angle R would equal 69 degrees. All right, so the next example, surveyor measures a baseline to be 440 meters long, and so MN is 440 meters. And he takes measurements of landmark P from M and N and finds that N to M to P is 46, so the middle letter tells you where your vertex is, and M to N to P is 75 degrees. And it asks you to calculate the perimeter. So the perimeter would be the sum of all the side lengths of that triangle. So we need to find the two missing side lengths. So we set up our law of sines here. And I'm not going to write out all three of them again. I'm just going to start with one of them, sine of P over 440 equals sine of 46 over side M would be across from that. Now, it looks like we don't have enough information, but we do, because angle P we can easily figure out. We've already got the other two angles. So angle P would be 180, subtract, excuse me, sorry about that, subtract 46 and 75. So that would give you 59 degrees. So we've got sine 59 degrees over 440. Oops, no, where I got 1440 from. Over 440 equals sine of 46 over M, and then we cross multiply and get M sine 59 equals 440 sine of 46. So M times the sine of 59 then would equal 440 times the sine of 46 which is 316.5095, so on the calculator. And then I would divide both sides by the sine of 59 to get rid of what's in front of, or what's multiplied by m, so I can get out m by itself. And then that divided by sine of 59 will be 369.2505 dot dot dot. So around 369.3 if we want to round it to one decimal place for now. And then the last one, we'd have sine of p again, I know is 59 degrees, over 440. We'd set that up equal to the other one, which is sine of 75 over side n, and do the same thing. So n times the sine of 59 would equal 440 times the sine of 75. So n times the sine of 59 equals 425.00736, so on in the calculator. Then I want to divide both sides by sine of 59 to get n by itself, and that will give you 495.8277, so on. So we round that to one decimal place, be 495.8, and that would be meters for both of those. And then we have one more thing left to do, and that's find the perimeter. So the perimeter would be the 440 that we were given, plus the 369.3, plus the 495.8, and that gives you 1305.1 meters, which is to the nearest meter 1305 meters. Okay, last question is a little bit of a lead up to the last section we're going to be doing, but you should be able to do this one now based on the information that you have about solving triangles. So when we look at what we're asked to find side MN, which is in a right triangle. But if you look at the right triangle M to O to N, you only have one angle, 42 degrees, and no sides. So you could figure out the other angle, but it's still not going to help you. You need at least one side. So you can't start with the right triangle MON. So if you move to the other triangle, MOP, and start with that triangle first, you see that you have an 18 degrees angle here, right here, and the side of 1,050 meters there. And that's all that you're given, but you can easily figure out this angle here because it forms a straight line with the 42 degree angle. So that would be 180 minus 42 degrees, which is going to be 138. And then you can figure out this angle, because if you know that this is 18, angle P is 18, and the one we just found is 138, then they all are angles in a triangle. So 180 minus the 138 minus the 18 would leave you with an angle of 24 degrees. So we've got three angles and one side in triangle MOP. So if we start with that angle, we can use the law of sines. We can use sine. I would use the 24 degree angle because I know the side across from that is 1,050. And then I would match it up with the 18-degree angle, and I'm going to put a y right here. Y, a sine of 18 over y, would give you that side that is also a side in the right triangle that we're trying to get to. So that's why I picked that one. So sine of 18 over y. So if we cross multiply that, then law of sine says that they should be equal to each other. So y times the sine of 24 equals 1,050 times the sine of 18. And that should give you y sine of 24. 1,050 times the sine of 18 is 324.467. And if I divide that by sine of 24, they cancel. I'm left with y equals, and that will give you 797.73. So if I'm rounding that to the nearest tenth, it would be 797, or to the nearest meter, is it? I'll just keep it to the nearest meter because that's what 1,050 is, to the nearest meter. So if we round that to the nearest meter, it would be 798 meters. Then if we go to triangle MON, and it's a right triangle. So we've got, if you look at MON now, or just draw that out for you. Oops, that's O. And M is up here and N is there. We know that this is 42. And we know that this here is 798. And this is what we're trying to find. And that's a right triangle. So we've got the hypotenuse, and we're looking for the opposite. So we would have sine of 42 is x over 798. And then we can put that over 1 and cross multiply and get x equals 798 sine 42, which is approximately 533.966 so on, which is 534 if you round it off.